Imagine a world where a 1,000-mile journey across the rugged landscapes of 8th century Europe could be completed without a single blister appearing on the traveler's heel. This was not the result of hardened skin or mystical endurance, but rather the outcome of a sophisticated understanding of material physics and geometric construction. We are exploring the 8th century turnshoe, a marvel of ancient engineering that utilized a frictionless interface to protect the human foot. To understand this technology, we must first examine the raw material, the hide of a mountain goat, specifically chosen for its unique collagen density. Unlike cowhide, goat leather possesses a multi-directional fiber matrix that allows for extreme flexibility without sacrificing tensile strength. The preparation begins in the tanning pit, where the hide is submerged in a solution of crushed oak bark and stagnant water for several months. During this time, the tannins slowly penetrate the fibrous layers, replacing the water and stabilizing the protein structure of the skin. This chemical process is essential for creating leather that remains supple even when subjected to the moisture and heat of a walking foot. Once the tanning is complete, the artisan begins the critical process of grain orientation, a technique lost to many modern mass production methods. By observing the natural growth patterns of the goat's skin, the craftsman can identify the direction of maximum resistance to shear forces. The heel piece is cut specifically at a 45-degree angle to this grain, ensuring that lateral movement is absorbed by the leather's internal structure. This alignment allows the shoe to expand and contract, in harmony with the foot's natural elongation during the gait cycle. We now turn our attention to the construction method itself, which involves sewing the shoe entirely inside out. This technique, known as turnshoe construction, ensures that the seams are tucked away within the interior of the shoe's structure. The artisan uses a curved awl to punch holes through the edge of the sole and the lower margin of the upper leather. The holes are spaced exactly 3 millimeters apart, a distance calculated to distribute tension evenly across the entire seam. A thread made of hand-spun linen is then heavily coated in beeswax to provide both waterproofing and lubrication. As the needle passes through the leather, the beeswax fills the void, creating an airtight and watertight seal that prevents internal friction. The double stitch method is employed here, where 2 threads cross each other within the thickness of the leather itself. This creates a hidden buffer zone, meaning the foot never comes into contact with the physical thread or the knots of the seam. Once the stitching is complete, the shoe is thoroughly soaked in lukewarm water to soften the fibers for the turning process. The artisan carefully reaches inside the wet leather and begins to peel the shoe right side out, a task requiring immense thumb strength. As the shoe is turned, the internal seams are compressed, creating a smooth, rounded edge that mirrors the anatomy of the human heel. This rounded interface is the primary mechanism for neutralizing the lateral shear that typically causes skin delamination and blisters. We must also consider the moisture-wicking properties inherent in the grain side-in orientation of the leather. Because the grain of the goat leather faces the foot, it acts as a capillary system, drawing perspiration away from the skin. The dry environment created inside the shoe prevents the softening of the epidermis, which is a leading factor in blister formation. Furthermore, the absence of a rigid synthetic sole allows the foot to engage directly with the ground's topography. This tactile feedback encourages a mid-foot strike, reducing the repetitive impact and sliding motion at the rear of the shoe. The heel cup is designed with a specific geometric curvature that locks the calcaneus bone into a stable position. This stability is maintained by a thin leather thong that wraps around the ankle, acting as a secondary suspension system. As the wearer moves, the leather thong distributes the weight of the shoe across the dorsal aspect of the foot. This prevents the heel from lifting and rubbing against the back of the shoe, even when climbing steep inclines. The internal surface of the shoe is treated with a mixture of animal tallow and birch oil, creating a microscopic lubrication layer. This layer allows the foot to slide just a fraction of a millimeter within the shoe, dissipating energy before it can damage the skin. The physics of this interface is a perfect balance between grip and slip, a feat rarely achieved by modern rubber-lined footwear. By analyzing the wear patterns on archaeological finds, we can see that these shoes lasted for hundreds of miles of continuous use. The edges of the leather show signs of compression rather than abrasion, proving the effectiveness of the hidden seam. Even the thread itself remains intact, protected from the elements by the surrounding leather walls of the turn shoe. It is a design that prioritizes biological compatibility over aesthetic complexity or ease of manufacture. In the quiet workshops of the 8th century, the rhythmic sound of the awl and the scent of oak-tanned leather defined the peak of ergonomic science. Every stitch was a calculated decision made to ensure the survival and comfort of the traveler. As we reflect on this ancient geometry, we see that modern problems often have very old, very elegant solutions. The turn shoe remains a testament to the power of material intelligence and the deep observation of the natural world. The goat leather, the linen thread, and the beeswax work in a silent, mechanical symphony to preserve the integrity of the foot. Within this frictionless environment, the stress of the journey fades away into the soft, rhythmic movement of the stride. The traveler can focus on the horizon rather than the pain of the path, held securely by the wisdom of the artisan. The subtle cooling of the leather against the skin provides a constant, gentle reminder of the shoe's protective embrace. As the sun sets on the 8th century landscape, the footsteps of the weary traveler remain light and unburdened. The hidden physics of the turn shoe have done their work, quietly maintaining the boundary between the body and the earth. We close our examination of this ancient footwear, appreciating the silent genius contained within a simple piece of leather. Rest now, knowing that the problems of the modern world are often solved by looking back at the mastery of those who came before us. The patterns are drawn, the leather is cut, and the stitches are placed with a precision that transcends time. The journey is long, but the heel is safe, protected by the invisible geometry of the past. Discover more history by watching the next video. We're eager to share more with you. You can't go wrong. All our videos are deeply detailed, dull while fascinating, and distinctly sleep-inducing.